Good morning, everyone. It's my pleasure to introduce Jeffrey Nickerson from the Stevens Institute of Technology. And, you know, something struck me as I was thinking about a way to introduce him. Julio Otino gave me the perfect way to introduce him. Julio gave us that very sticky observation that rationality is the servant of man, but intuition is our gift. And I think if anybody's research really represents bringing together those two ideas, it's really Jeffrey's. Jeffrey studies everything related to social networks, and I mean everything, like across the board. He studies social networks, he studies computers and machine networks, and then he studies man plus machine networks. So he covers the whole spectrum. And I'd have to say, in terms of his delving into the gifts of intuition, some of his work on crowd IQ is the best that I've seen. So I'm really looking forward to hearing his talk today. And Jeffrey, let me thank you very much for joining us. Thank you. Bye-bye.
Thank you. Well, it's, I changed my slide because I realized that, that I had to acknowledge everyone in the room. At first I said, well, I should say practically everybody in the room, but then I realized the people that I don't know their papers yet, and I haven't cited yet, I'll probably be citing after the conference. So I think this is a remarkable set of people, and truly many of you are people that have influenced me, even if we haven't met, and many of us have met, and have been, and many of you have been very helpful to my own research and the research of my students. So I'm going to show some examples at first to give you, again, the introduction says kind of I do lots of things, and so I'm going to talk about several different things. What I'm trying to do is I'm trying to, you know, what happens in these situations is once you go into a domain, you learn a domain very well, and the question is always, can you generalize it? And one way to handle that is to work in several domains at once and see if, as you're doing that, some things seem to be happening in those few different domains. And so I'm going to take you through a few different pure production domains where I see some things happening that seem to at least have parallels between them. So some of this work started from some experiments we did with crowds, and what we did is we essentially made a human-based genetic algorithm. And so what we did, we would ask somebody to draw a chair. We paid them between 25 and 40 cents on Mechanical Turk. We'd ask somebody else to draw a chair, and then we would give the two chairs to somebody else and give them 40 cents to combine the chairs. And so what was really interesting is we have no idea whether people could really do this and whether it would turn out well. And it did turn out well. And it was interesting because we could start to see how some of the features, like the little triangle features, moved down from that chair, and some of the roundness of that chair moved down, but this part of the chair moved. So people were really doing this kind of feature merging. And when we asked them later about what they were doing, they were able to identify and say, oh, I was taking the cushion from this one, it looked kind of round, I was taking the pattern from this one. So they really were able to articulate how they were combining things. And so we thought that was remarkable. The limitations of this kind of research is none of these people were professional chair designers. And so one of my other students, seeing this student doing it, said, well, I think this is happening online. Let's see if we can do something observational and find this happening online in pure production environments. And that led us to look at a pure production environment called, I know what it is, it's this cable, Thingiverse. And in Thingiverse, what people, I think it's the, I think it's actually this cable. Okay. Oh, this is going to be annoying. I have to like stand on the cable, right?
Let me help.
Okay. So what we saw was.
Perhaps you have to plug in strongly there.
Well, we have the export coming, so.
Okay. So, well, I'm just going to talk while they try to figure out. So what we really saw was the people were doing exactly this. They were finding two objects in a pure production environment. These are designs for things that could be printed on 3D printers. And they were themselves, they weren't being forced like we did in our experiment. They were finding these two things and saying, hey, if I take a tripod mount for a Kinect and then I take the handle of an AK-47, because, by the way, people do build guns in these environments too, and put the tripod mount on the AK-47, and then screw the Kinect on top of it, I will now have a 3D scanner, which is really, really useful to people in the 3D printing community, because they can go around, they can scan around things, and then they can create new objects. So it was kind of heartening to us to see that this was actually happening in the wild. And then we're like, well, how hard could it be to figure out what's really going on? Turns out it's really difficult to figure out. This doesn't happen all the time. In fact, it happens fairly rarely. But there is this process through which these people are finding each other's work and collaborating with each other. I need to just flip so at least I can keep my train of thought going. Yeah, so what I'm going to do in a second when this comes back is I'm going to show you what the trees look like in this environment. And these kinds of reuse networks have trees that have a variety of different topologies. So one extreme is the tree where you have a design, and then you have a lot of other designs coming out from that design, and then nothing happens. So in other words, there's a reuse of this thing, and then there's a family of designs around the thing, and then it stops. Okay? That's like one extreme. Then the other extreme is where you have just a chain. So somebody does something, and then somebody modifies it, and then somebody modifies something else, and they modify something else, and so you get these long chains. Now, this happens in this 3D printing environment. It also happens a lot in Scratch, and in Mako and I have talked about this a bunch, and Aaron and I have talked about this. And what happens is that in an environment like Scratch, where people are remixing programs, there's certain kinds of things where you get this topology. And one example is a contest. Now in Scratch, the contests are really interesting and different, because in Scratch, the kids themselves, usually they're 8 to 15-year-olds, they decided on their own that they would throw their own contests. And they would say, please, here's something to color it in, and I'll give you a reward. And the reward are social media currency, which are likes, okay? Or things like that, or acknowledgements. And so they throw these contests. Now, it's kind of obvious that in general, what's going to happen when you do this is that people are there's only going to be one entry to the contest. In other words, you're not going to remix somebody else's entry, because then it's not really your entry. And so the contest itself kind of defines this set of gravity, but not always. So sometimes the kids will do the following, which I find so fascinating, is that it'll be a coloring contest. There'll be two anime characters. They'll fill in one of the characters, and they'll say, hey, anybody want to help me fill in the other character? And then somebody will remix that and send it in, and really it's a collaboration between the two people. It doesn't happen all the time, but they kind of made that up. Okay, thank you. So this is what it looks like inside the Thingiverse environment. These are robots, and everywhere there's a line, it means that somebody took one of these designs and actually modified and changed it. And they attribute it when they do it. They form links to them. And we've checked to see if they are actually using these things, and they are. We can look at, essentially, I'll talk about it a little bit later, we can essentially look at the source code of these objects, and we can compare the shapes and everything else. So we know that these networks are pretty good. The same way in Scratch we know they're pretty good. And here's a few examples of these topologies in Scratch. Like the one I was talking about is like that. And then you get this, which is kind of like that first one, but almost like, oh, there is a little bit of a kind of, remix of the remix going on there. And then they've got that stream coming off to the right, which is serial. So this is kind of a mixture of those two different metaphors. Okay? And here's another one, right? So you see kind of more of them. Most of them are around that core, and then they're moving off. And you get things like this, and I think if I got this one right, what's really interesting is that this one right here is the initial node. So what happened is this initial node got remixed 3 times, and then this one, for some reason, caught on. Okay? it's not, it's not that usual for that to happen, but it's a possibility in these environments that it's the thing that gets picked up. We know in academic literature this happens, right? Somebody writes a paper and then somebody else like reframes it in some way, and essentially when you go back to the root paper, it was pretty much all in the root paper, but the packaging and the timing and the publication or whatever generate the citation. So it's a little bit like that. And then these things, this is which is what I love. You get the sense that there are two centers and maybe a third one emerging, right? Okay. And then this, which is, and in a sense, in some of these cases, what's happening is that a few of the kids are kind of breaking off, and they're working back and forth with each other, right? So they're picking something and going like this. So I wanted to, I'm doing this just to give you I think it's helpful since we're going to be talking about that to see lots of examples, and I'm going to try to find some patterns in it. But right now I just want you to see this stuff. This is some, oh no. Okay, how did our AV person fix this? I think what it is just. I need somebody to get the AV person back again, I think. She's on her way. Okay. So let me talk about this a little bit, and maybe we can get this stabilized. So these are, this is another environment we've been looking at, which is collaborative work with Tom Malone at MIT, and he's been running a community of people writing proposals for climate, related to climate change. And there are contests every year, and there are cash prizes for these contests, and there is an award ceremony which I went to a couple of weeks ago for these things. And so there's quite a lot of fairly activist people who are involved in this stuff, and they're putting a considerable amount of time into writing the proposals. And the Climate Collab people decided to try to create a very structured kind of proposal where you would have a contest for a regional proposal like the United States or China or like that, and you could reuse other proposals to create the regional proposal, and then you could write a global proposal, and you needed to specify each of the regional proposals you would use. And so the idea was to kind of force people to look at and use each other's stuff, and in a way to start to get people to create components that would be reusable, because a climate change proposal is a lot of work, and not everybody's expert in every part of the world or every technology, and so the idea is that maybe over time we'll get better and better proposals by doing this. And so this is data from just a couple of weeks ago, because we finally have, this is the first time we've done it, we finally got back what people did. And in fact, if you can kind of remember what I showed you there, they did do what we hoped they would do. In other words, they did really select proposals, and sometimes they created the proposal they selected. We allowed them to do that. And that's okay, because once they created that proposal, it became reusable by other people, and it was reused. So one of the incentives was, if you don't see anything good, you can create your own. We were afraid we would get all of these, we would get no crossing, that people would just create their own sub-proposals. But it turned out that they did things and they reused, and we get the kind of nice graph, and we get the distributions we would expect, with some things being recited a lot and other things being recited less. What we're trying to figure out, this is kind of new data, we're trying to figure out if there are, besides the kind of forced categorization we did, there's a lot of other proposals that people pulled on from past years in different regions or around particular topic areas. So as an example, there's somebody who's really into using algae. And so the algae proposal gets wrapped into some other proposals. There are people who are putting solar, who are doing desalination, and those work into other proposals. We're trying to figure out if there's a kind of a right level of modularity which causes people to be more likely to use it. Maybe too specific is bad, and maybe too general is bad. We're not sure. And so we're looking at and trying to understand whether we can make some predictions about what things get used, right? Obviously, a lot of this has to do with the quality of the work, but in some cases, the quality of the work does have to do with how well they do the integration, and so it does have to do with how they actually made the choices. Okay. So that's that's another environment. Another environment we've looked at, and I won't talk about it very much here because we've just seen a talk on it, is we have been looking at Wikipedia. Another student's been looking at that, and what she's particularly interested in is in the kind of collaborations that people do on the pages, what is the shape, what is the kind of modularity of not the ostensive group, but the performative group? In other words, we can look at and see who's interacting on the pages. We can form them as clusters, and we can look at how modular they are in terms of looking at topics. Okay, we can use community detection. What we're interested in is how does that community detection relate to things like the productivity of the group in terms of pages created, and also to things like, you might call it efficiency, which is the number of reverts, right? And so what we're seeing, and it's not going to sound unusual to many of you who study Wikipedia, is you're seeing the modularity seems to be predictive of, or at least associated with, a fair amount of both productivity and efficiency both. And we're trying to get to the left-hand side of that. In other words, okay, if modularity is good, what is causing that kind of modularity to emerge, and how is it emerging? This is performative, so this is not people going in and intentionally doing this for the most part. It's people who are kind of naturally associating with each other. And by the way, we did look at things like homophily, and we are not seeing, we expected to see lots of homophily in the groups, and we did not. We actually saw kind of a fair amount of diversity in the groups. It's more like a rock band where you have a drummer and you have a bass player and like that. It was more like that than everybody does the same thing. So, so you can start to see some themes emerging in what we're looking at. In some of our environments, we're looking at things where people entirely work on their own. Like in Thingiverse, there's no such thing as a team. Everybody works on their own. They take designs from other people, and you will see sometimes they'll go back and forth with somebody. There's no idea of getting together on a team. Wikipedia, there's more of a sense in the groups, maybe, of having that. In the Climate Collab, there certainly is. There's a very strong sense of group. And in the Climate Collab proposals, what we look at is we're looking at how, at kind of within the group, when they modify their proposals, and we're very thankful that they do this, they do it online. And so we can see their revisions, and we can see within a team how somebody does like 3 revisions, and then somebody takes over and does 3 revisions, and somebody takes over like that. So we can look at that very fine-grained way that they're creating the proposals, and we can look at the effects of the comments that are coming in on the proposals and see what effects they're having. Okay. Think it's working?
I think we're working.
Okay. Do you have any idea why it's going in and out?
I don't, but I just changed the setting on the computer to mirror the displays, and that seems to have solved the problem.
Okay. Just for everybody else? Okay. Okay, so these are, I'm going to now, all these things I showed with my hands you can see for real. So these are the top ones were the global proposals. It's global, and then regional, and then these are other things that people pull in. And we actually think that this is really interesting because we don't give them any force function for pulling these other proposals, and they'll go back several years and pull something from previous contests. Or they'll pick some very, very specific technology and bring it in. So we think it's an interesting kind of data. And the other thing is that we can, if we want to, we can perhaps do experimental manipulations in this environment. Okay. So to talk a little bit about who's doing what. So UA is a graduate student who will graduate next year working on Scratch and on the Climate Collab. Pinar is working on Wikipedia, and Ann Maishak is helping us with our kind of next round of this investigation. I know many of you, I see a big USC contingent. And then Harris is working on Thingiverse, and Gaurav Sabnis is a marketing professor at Stevens that we brought into it because we started to realize that we were looking at product networks, and some of the marketing stuff actually turns out to be, that perspective turns out to be very useful to us. Okay. So now I'm going to get So now I'm going to show you networks or absence of networks more theoretically. So a lot of environments, there is no reuse. If you have a suggestion box or something, or people are putting things in, nobody is reusing other people's stuff. If you do when we do tests in school, our supposition is that people aren't reusing what other people are doing, right? So this is kind of one way of working in the world. This is reuse, where, for those of you who know object-oriented programming, this is single inheritance reuse, meaning you can reuse one thing. You can pick one thing and you can modify it. So Wikipedia is like this, and Scratch is currently like this too. In other words, you can take one thing and you can modify it, and what you get is you get tree structures. In something like Wikipedia, for the most part, you get this. Okay? In other words, you get modification after you get these kind of linear change that I've talked about. You can say that some events are like forking events. There's a little bit of, when a page gets too big, you fork it, and you can say that those events happen. But for the most part, it's very linear. In Scratch, it's these kinds of trees. In Thingiverse, they allow multiple inheritance. And so theoretically, it can look like this. I will say that if you really go look at the statistics, a lot of it is still tree-like. In other words, not that many people do multiple inheritance. Multiple inheritance is hard. You have to find two things, and you have to figure out how to integrate it. So it's not the norm. It can be done, and when it's done well, it's where a lot of really nifty things come from, but they don't do it a lot. And that's one of the things we found in looking at the environment is we couldn't base our analysis just on, we thought we would find like thousands of those really cool combinations of the connect, but no, there are tens or 20s of those, not thousands of them. Now, a little bit more theoretically, looking at the graphs. So in a place like Thingiverse, one of the things we realized fairly recently is that we were drawing the graph between, say, between one object and another, we were ignoring the thing in between, which is the transformational tool. And in some environments, the transformational tool is just a text editor and nobody really cares very much. It's kind of all the same. But in environments like Thingiverse, it actually matters a lot because there are different types, right? So there are people who work on 3D designs. They either work on surfaces, which are sets of triangles, or they work on solids. These are two, both of them are equally valid ways to work on, on three-dimensional form, and they have different tools associated with it. And so for the people working on the kind of, well, I'll say facets for F, that's a facet file. It's a set of triangles. And if you go into a text editor, you could theoretically change it, but nobody has enough memory to, in their mind, remember all these triangles and get the coordinates right. So you use a tool, and the tool that most of these people use is called Blender, which is an open source tool that allows you to manipulate surfaces. So you bring in a surface and you stretch it and do like that. It's not easy to use either. It sounds easy, but if you tried, it takes a lot to do 3D design. And you can do multiple inheritance, and the multiple inheritance is happening inside the tool. So you take two files and you put them inside the tool, and now you got two sets of triangle files, and now you play around and get them to touch each other, and that means that now connecting, now they become one object, and then you stretch and you like that. So you can do it. But the important thing is these become bipartite graphs, and when you do this, you become more conscious of what the edge really means, that there's a box there, there's a transformational process happening. And not in all remix communities, but in some, I think this actually is pretty important. This is, the solid modeling is taking place in this community in something that looks very much like source code. It's a language called OpenSCAD. And you can say sphere at location la, and you can write subroutines, and you can write mathematical transformations like it's source code, and you can manipulate these 3D objects. And so how do they edit that? They use a text editor to edit that, and they create a new one, right? And so at every step in these remix networks, there is kind of a sequentiality. We know what things came first. There is the potential. You can take these two text files, as you can any open source files, and just manipulate them. There's a lot of malleability here. And actually, both of them are malleable, but they're qualitatively different. You know, at first I kind of wanted to say that this is like true malleability because it's textual source, but I'm not sure that's really the right way to look at it. I think there are different kind of modalities. I think there are some advantages to both, and some of those advantages have to do with what kind of thing you're designing and what you know. Okay, so so now that we've looked at, I know. So now that we've looked at a couple of at some more abstract graphs, I'm going to come back, and this is going back to the Scratch data. And Scratch data is source code data. And what we are able to do with source code is we are able to do things like compute string edit distance, which gives us, it's one measure. It's not the only distance measure you can have, but it's one fairly easy to compute measure that tells us how far apart things are. And then we can draw graphs like this, where since we have distance matrix, we can use multidimensional scaling to scale down that, basically high dimensional space into 2 dimensions. And we can start to look at what these, this way we can look at both the topology and the distances and maybe get some insights into what's going on. And here's the 2 extremes I was talking about before. This is a project on Scratch. And you can see what's interesting is that, the topology and the distance are not necessarily correlated. In other words, this is just one step away from the main thing, but it's really, really far. And there's a couple of things that are, it's hard to see here, but a couple of things that have had a couple of generations, but they stay very close. So the topological distance is not the same as the string edit distance. Okay? And on the right, this is a Climate Collab proposal, and this is showing 2 people who have alternated their variations. And you can start to read some things in, is that this was kind of a big change, then this person stopped, and this person picked up, started with a little small edit, and then did a couple of big changes. And then this person came in after this person's big change and made a couple of little tweaks before the project was finished. Right? So we're dealing with different environments, but we're using some similar ways of graphing it to try to get a better understanding of what's going on. And I just want to show you, to take these nodes and make them real for you. So this is something from, again, remember these are adolescents for the most part. So this image corresponds to the big circle there. So that's the core image. Okay, and you notice that somebody made a very small change, right? So somebody just took the thing and just made a small sketch change. And you can see that we're moving like that. But then somebody else did, so somebody else did something really fairly major, right? So what they did is they changed the background and they introduced a new character into it, right? And so, so you get a sense in remixing, you can have these kind of very incremental forms of innovation, and you can have these much more radical forms of innovation. Now, if we start to look at the graph diameters of these things, these are the kinds of varieties that we see. And so one question we had was for those of you who've looked at Scratch, this may make sense to you, is that it turns out that the graph diameter has a lot to do with the type of project. So and coloring contest is like the contest thing. So it tends to have a very short diameter. Games, on the other hand, okay, question for the audience. Why would games have a larger diameter than coloring contests?
You have to explore the play mechanics.
That's part of it, but there's something else about game structure. Yeah, Nico.
No, I was thinking about coloring contest structure in terms of the very shallow nature of the way in which those are used.
Right. Well, here's what we think it is in games, and we're pretty sure about this. What these kids do in games is they keep on adding levels to the game. Okay? And so, there's 5 levels, and they'll say, hey, can you add another level? And the games keep on getting longer and longer and longer, and sometimes the levels get more and more ridiculous. But still, it's a form of innovation, and it's a more serial form of innovation because of the way it's structured. And animations are the animations in games are really similar on Scratch. The animations are, in some ways, super interesting because they're often a bridge from the kids who come in and just do coloring contests. Once they start doing animation, they learn a lot more coding. And so that's their bridge into real coding. And then some of them actually, the game stuff is probably the most intricate stuff, and at least in general, the game stuff is probably the stuff that's got the most, calls for the most programming skill. But we think this is kind of interesting that the diameters are so different between these different categories.
What's going on with the animations that they're so much deeper?
Again, with the animations, so the animations are very much like games, except you don't have score. So the animation, it can be adding another character. And like, here's the game I'm going to introduce, kind of like I showed you before, there's this character, now you add another character to it, and now you add a story, you add kind of, sometimes they're like stories. So there's like essentially chapters. And I think, Mako, I think they even say chapters in them sometimes.
How are you identifying these different classes of remixes?
This is hand coded. So we go and we look at them and see. Okay, yeah. So yeah. So sometimes they can be, if you try to do it automatically, you can misclassify. But if you go and look at them, it's pretty obvious what they are.
Yeah.
But I think, but in animation, do you agree with the animations often has this kind of like, sometimes there are like, there's like chapters where the kids add chapters.
I also see there's more variation as well, which
Yes.
In the sense that what happens in animations is going to be, people do all sorts of things within animations, whereas games tend to be much more structured. They also tend to use libraries much more in the sense that people, when they start to make a game, will often not know how to do, the games are doing things that are very complex, and there are patterns within Scratch that you'll see, like, as far as I can tell, they were created once and they've been redone many times, so.
Yeah. He'll keep it near him. He'll have other comments, I'm sure. Okay, so this is just seeing this in a different seeing these things in a different context. So the other thing kind of related to this is, well, okay, so and things like the Climate Collab, where you don't have kind of these nice game structures. You just have a proposal structure. What causes people to do a lot of revisions, right? And it turns out that one of the things is that people give them comments and say, I'm wondering whether you've seen this particular proposal. Okay? And often this is just like very honest advice. Sometimes it's a little bit of self-marketing. But these comments come in, and then we can look at the comments, and we can see that in some cases they see the comment, they don't even reply to the comment, they just do it. And so this is additions, and that's proportional in size. So it's actually a reasonable, this wasn't a very big proposal, so it's kind of a reasonable addition happened pretty much right after that comment. And here's another example of this. And this is kind of interesting because this looks like a reply to a reviewer almost, right? So, you are right, I need to do this. And then they do it. They add 3 paragraphs to it. And so this may be obvious, but we think it's kind of interesting that these comments, that you can kind of trace this, and these comments actually do have, it seems like this, this effect on the diameter of what's going on. And so we tested it with a simple regression, and we found out that at least for this, we didn't control for everything, but it does look like the comments explain some amount of the variance of what's going on in terms of the graph diameter. In other words, if there are more comments, there will be longer graph diameter. And we know the comments are coming before the changes because we're matching the comments to the actual changes to make sure that this is a cause-effect relationship. Okay, now I want to shift to what I think is the kind of the weirder world of the 3D printing community. And I want to show you an example just because I think it's like it shows you how strange the digital can be. So this is a scene from a game, okay? From inside a game. And you see that candelabra there? So somebody decided to reproduce the thing they saw in the game in the real world. Okay? So that's it inside Thingiverse. Okay? They figured out the way to make that again. Those are glow sticks. So they put glow sticks on it to give that kind of luminescent effect that you saw inside the game. So it's kind of like the real world imitating the game world, which was imitating the real world. Okay. I think what's so interesting is, I know this is a lot of text, but first of all, I love this. Cyber Renaissance, and the game is Cyber Renaissance and Artstyle, is a printable, good-sized glow stick candelabra to bring a little neo-noir class to your home or work, right? Pretty well written. And then down here, I had to take a few liberties with the design. I went for a sharply faceted holder, which I personally prefer. I like the low poly look, right? So a small number of polygons, right? Kind of like in the old days of games, you didn't have these really great graphic engines. You would have less polygons, and it would look like that. And so she's actually imitating this effect. So I just find it's a fascinating example. And then this is what somebody printed this, and they put a picture in of themselves printing this on a 3D printer. So you get the idea of what these people do. And by the way, I don't know if you caught it in the other one, but it takes about 8 hours to print this thing on most printers. And it gets remixed by other people. Okay, so that's kind of as a kind of preface to thinking about what's happening, about the way reuse is working in this community and I think in some other communities. So ANN-SONIC has this management science paper, which I think makes this really interesting distinction between reuse for replication and reuse for innovation. And so, as an example, reuse for replication might be, I need to jumpstart my car and I can't remember how to do it, so I download something on the internet, okay? I just want to replicate what those instructions say. I do not want to innovate, okay? I do not want to try to red to black and black to red. I want to try red to red and black to black. I just want to copy what's there. I want to get it done. I consume that instruction. I don't look at it again. Reuse for innovation, the more extreme part of it, which he discusses in the article, is you're at NASA and you need to build something to detect sandstorms on Mars. You need to go out and find something somewhere that will be useful for doing that. That's reuse for innovation, right? And so a lot of things do fall into those categories pretty well. But Thingiverse introduced a few years ago something called a customizer. And we know about customizers because we've used them. They're also called configurators. They're called toolkits. They're sometimes called co-design platforms. But I think the other ones are more common terminologies. If you go to Adidas website, you can configure a sneaker. And you can configure a lot of things about the shape and the images on the sneaker. So these things have existed in mainly consumer environments. But what they did is they put this inside what's really a maker environment, and so that you could both use the customizer and create customizers, because this is all open source, right? And so this really changed things inside the community. So here's an example of, so this is there were many USB stick holders designs, but then somebody created a configurator of USB stick holders. And the configurator allows people to kind of change how many they're going to have, whether they're going to have 2 columns, whether they're going to have numbers on them or personal names or like that. And so basically, you can create a family of designs using the configurator. And so we call this, tentatively for now, reuse for customization, because it's different. It's like replication because you're not really making any kind of drastic innovation. But it is an innovation, right? It's different from the thing before. So it's got this quality, and it's very easy to do. You don't need a lot of skill. You don't need to integrate anything. You just need to change a few parameters. So it's like replication, but it creates something new, okay? And it creates, as we'll see, it creates a very different behavior inside the Thingiverse community when it's introduced. So this is an example of what a customizer looks like. This is for a whistle. I don't know if you can read it, but the radius of the whistle, the height of the whistle, the length, you want a handle? Do you want text? Okay, so you can personalize your whistle. So you can modify this. You can modify this whistle by just dragging these things around, and what you get as your output is you get a design in the surface format, in the triangle format, that you can then send to a 3D printer. So it's a customizer. And it's just like the customizers, that Adidas had, except you can modify the source. And here are examples of whistles that people have created with this customizer, right? So really, what it does is it creates families of designs. Now, how does it technically work? The STL models, those are the surface models that I show up there. You're not going to want to edit that stuff by hand. This down here is the OpenSCAD models. This you do need to edit by hand. The only way to do this is with a text editor and a little bit of programming ability. And the customizer has this kind of, what they did is they just kind of tacked on something to OpenSCAD, and it allows you to specify certain kind of parameters. Those are the things, these are the things that you're going to drag around. And these things are comments, but they're read by basically an interpreter that says, okay, that means the radius has a range between 20 and 50. Because of the square brackets, that means we're going to put a slider bar there. That's all it is. Now, what does this look like in terms of a graph? Well, I think the interesting thing here is that these customizers are really made up, I believe, of three components. One is that kind of the source code model, right? The shape itself. Another is the meta model that says what parameters can you move around in that shape and what are the ranges. And then the third thing is an interface, meaning you can drag these parameters around. You don't have to understand the model. You can just drag the parameters around and you can generate something new. So when this is presented in an open source community, there's two ways people can use this. One way they can use it is they can run the customizer, just drag things around and create these facet files. The other way they can do it is they can go in and edit the source and create another customizer. So it gives two pathways. And what it turns out is that as you might expect, these things are so extremely popular that once one of these things is created, sometimes hundreds or thousands of these designs are created down here. Okay? And these designs, however, are not reused at all. Why would you, right? It's kind of like they're too specific. I mean, you might see a whistle there that you think is a decent whistle, but you might as well go back up and tweak it just to be perfect for you. And so in a way, what I'm going to conjecture here is that there's a certain gravity to the customizer, and it has to do with the fact it has more information in it, it's more malleable, and in terms of relative advantage, it has a lot of relative advantage over here. This is if you're a novice, you would go back up and do something like this. If you're an expert, you're going to go up and you're going to actually you might do this too, and they do, but you might go up here and you might try to extend the knowledge, that kind of meta knowledge, and add some things into it and create this other thing. So these things are attractive to both communities. Right? Now, so to add to the regressions you've had today, I won't spend a lot of time on this. So this is a zero-inflated negative binomial model. And the reason we use this is there's a lot of zeros in this, of reuse in all these remix communities, right? And we actually had a hypothesis that that if your design has been customized, then that means nobody's ever going to use it. And it turns out it's pretty much true. Okay? And it's not just the file type, because many people create STL files in Blender, and those do get reused. It's not just the file type, it's that way it got created. And so these things don't get created at all, and what generates a lot of stuff is the customizer is really quite powerful, right, in terms of predicting reuse. The other thing is that this last model here is an interaction between customizer and experience. As you might expect, in order to be able to really, if you're a very experienced developer and you work with the customizer, you create things that are highly generative. I think this makes sense because you take skill to actually create these things, and it takes community experience to get good at this and understand the community enough to figure out what kinds of things are people going to want to do. And so those things interact, but even when they interact, there's still very strong effects to just being a customizer. Okay, so we think what's going on here is that for the novices, the ease of use of these things appeal to them. They can create a shape very easily without learning 3D design. For the experts, what appeals to them is that, first of all, there's the challenge of creating these malleable metamodels. It's really challenging to do this. It's not so hard, but you have to kind of think about, what is a whistle? What are the components of the whistle? Am I going to think about the inside of the whistle, the ball inside the whistle? Am I going to change that? There's a whole bunch of design questions that you need to ask if you're going to parameterize an object, and that's challenging, so that might be part of the attraction. And again, once this meta-knowledge is embedded in this open source environment, it becomes easy for other people to access and extend it. So here are some of the side effects of this. So this is a quote from somebody. This person played with a customizer for the first time. This person hit a high of 881 views and 30 likes in one day, not intentionally, just because this person added a customizer front end on an existing design. So this person just took a design which was out there, as kind of an open SCAD file, and just extracted a few parameters and republished it like that, and all of a sudden got a lot of activity. Now, this also may be very reinforcing. So in other words, if this happens to you, it might make you feel kind of like your paper's being cited, and you might continue doing that kind of work. So that's one potential effect here. But there's a side effect that the people who created this didn't really think too hard about. So what happened when they introduced this is they had about 10,000 designs in the community when they introduced this thing. And about 6 months later, we kind of studied this for about 6 months, they had over 100,000 designs. And so if you look at there's this huge number of designs, and they publicize that. Thingiverse, 100,000 designs, largest like that, right? So, but some of the experts on their blog said our stats on how many of the 100,000 designs are just slightly different, useless custom variations of something, and how many are actual unique things, right? It's a really interesting question. And it's true, they weren't showing, but we can see that a lot of them are, at least half of them are these things that are variations on other things. And the second one I think is also interesting. The customizer is great, but you really need to adopt the search so that I can remove all the customized things that people put up there. At this point, it's almost useless. Right? So what's happening is people are creating all those objects, and then when you search for a whistle, you get whistle with Jeff's name on it. You get a whistle with Mako's name on it. You get all this stuff. You don't want, if you're like somebody who's doing reuse for innovation, you don't want that. You want like the generic whistle. That's what you want to work on, and you can't find it because you're seeing all of this stuff because they cluttered up the environment, right? It's really an interesting thing. Now, you could say cynically they're cluttering up the environment so they can claim they have 100,000 designs. I think that's part of it. But it's actually true. There have been studies that show that it's useful for novices to be able to see, how you use these things and what people have generated. So there's really an issue of how you change visibility and how you change search in these environments. So in other words, instead of just having reuse for replication, customization, and innovation, you might have to have corresponding, other processes might have to correspond. So in other words, if you're doing reuse for innovation, you want a very particular kind of search because you're looking for things that are good fodder to create your next, create a new design where you're going to push the envelope of knowledge and you're going to continue to write something that somebody else is going to cite. That's very different than if you just need to find something because you want to print a whistle. That's different, right? And so the search stuff is, if you just want to print something that's already there, then it's replication. If you want to customize something to put your name on it, that's customization. If you want to extend the knowledge, that's innovation. And probably these processes in in these kind of communities, they could be tailored. And in fact, over time, Thingiverse figured this out, but it took them a while. It took them well over a year before they started to realize that they needed to modify their search to allow people to, look for particular classes of objects. So now I want to ask, because I've been talking for a long time, I have a few more things I want to show you, but I want to kind of ask, since this is probably the best audience I could have for this kind of question, is what other domains are there customizers in, or things that kind of act like customizers in your favorite reuse or remix communities? Yeah, Kevin.
So it occurs to me that a lot of open source software does have the configuration files that make it useful. So if you thought about even like Apache Web Server, there's all the configuration files and all the modules you add on to get it to do exactly what you want. And when you are trying to set it up, often you go find someone else's and then tweak it a little bit. And in at least a few of them, there are these add-on programs that will write the configuration file for you. So you can have a nice graphical front end and click on a few things and it spits out, 150 lines of dense configuration file that you could edit if you wanted to.
But you don't.
Yeah. And similarly, I'm upgrading the router at home, and so there's this nice GUI for setting up all the router configuration files. But at the end of the day, they're just text files. And again, people will say, "Oh, here's the magic incantation to get a VPN running on your home router," and you could just copy and paste that in, or you could try to figure out what it actually does and tweak it so it does it a little bit different.
Thank you.
Yes,
Yeah.
configuration files.
So Jeff, I had one over here. It's closer to home. I suspect, just building on what Kevin had said, something that hits closer to home would be LaTeX setup files. I suspect we've all inherited like a LaTeX file from an advisor or a collaborator, and we don't know why we're putting all the stuff into this, but we do, and it works. But I imagine that's another site of some interesting variation. And I suspect that you could sort of discover disciplinary boundaries with these sorts of things too. Another one would be like online games too. So like a lot of times there's like modding cultures in online games, so that you can like remix a map. You can remix like the textures. So if you look at like something like Team Fortress is a game where people sort of remix like hats and things like that. So people call it a hat simulator where you shoot each other rather than a shooting game, but that has hats. So.
Excuse me, Jeffrey?
Yeah.
I just want to alert you to the time.
Yeah.
We want to give you a little extra time because we had a technical snafu, but we only have about 7 minutes left.
Okay.
So I'll leave it up to you. You could use the time, to talk about what you'd like, or you could begin to take questions now on what we've already talked about.
Well, let's keep on going with a few of these things, and then I'll have maybe a couple of minutes of summary at the very end.
Okay,
Yeah.
fair enough.
Yeah.
Okay, I think another example of customizer is like a template in Wikipedia. So you can see, like in Wikipedia, for example, articles can belong to different wiki projects, and they use different templates to tag each articles. And these templates are like the different wiki projects. They customize the templates, and so I think that's one example. And another thing I think can be relevant is that in one of our recent work collaborating with Bob Kraut and Nick Guitar, and we look at how the mechanisms in wiki projects, that is called why it's called collaboration of the week, how this particular mechanisms is diffused and adapted across different wiki projects in Wikipedia. So collaboration week is a mechanism that attracts like Wikipedia editors to collaboratively edit 1 or 2 articles during 1 week or 1 month. And we found that this mechanism is diffused across different wiki projects, and when they are diffused and transferred, and the people adapted and modified this collaboration of the week. So that's another example, I think.
Yeah, that's very interesting. And that gets to something that I'm wondering about, is whether there are a lot of very literal examples of things that look exactly like customizers, but there are also these ones that kind of have centers of gravity around them, but they're not exactly like customizers. And one thing I'll go back to is to say, in online contests are meant to foster innovation, and they can be designed in many different ways, but it may be that the contest entry has, it kind of acts like a customizer. It has a center of gravity, and people will remix it, but people won't remix the entries. For example, in CC Mixter, there's this phenomenon that a song will be there and people will remix the song, but you don't remix the remix very often. You go back to the song, and so you get those kind of low diameter graphs. And so I think there might be these things, and I'm not quite sure how to define it. The best I can come up with is this, kind of an idea that they are central for some reason, and their descendants are not very fertile, right? And I think it has to do with meta-knowledge. It has to do with fixation. It has to do with all these other kinds of things, malleability perhaps. But there's something to that, and when we do this analysis of remix networks, it's probably pretty important to take a look at the types of things that are being remixed. Because we found that when we first did Scratch, we were like, if you average things in Scratch, it doesn't work. You have to figure out what those categories are before it makes any sense at all. And it turns out in Thingiverse, we even had to go down to the level of looking at the source and figuring out like what tools are being used, and then all of a sudden it kind of made sense. So my meta point is that these remix networks are very sensitive to type of object and type of processing, and that there's probably a lot of interactions between the types and the people, and that these and that in these pure production networks, things like customizers are exciting because they invite in lots of novices who can easily get something going. They also sustain people who are already there because they can build these more intricate things. And then it's just a matter of setting the rules and processes right so the novices don't overwhelm the environment with lots of junks, so that you can keep the people who are doing the harder kind of reuse for innovation, you can keep them happy at the same time the novices are doing what they do, and sometimes they do cross over and they learn how to code and they become the experts. Not always or not even often, but enough.
So three quick examples. Minecraft, there's all sorts of things that are exactly like this. The legislative process, especially in the United States where you have 50 states and you have political agencies and political groups that will try and create templates that generate legislation in the other states.
Oh, yeah.
And fan fiction and adaptations in fiction. So why does Harry Potter get readapted in different ways than Lord of the Rings, than Twilight, than Jane Austen with zombies? But so there's really interesting questions there, because literary adaptation is the kind of process you're talking about, just in a different, more diffuse realm. The question I had related to this is, how do you think the ability to imagine things that aren't there, how do you think this interacts with collective or individual imagination? So it seems like part of it is a customizer says, here's what you can do, and you run the risk of having an innovation ghetto. I mean, that's sort of what you're describing. Right. You go into this space and you can modify it any way the customizer allows you, and if you don't think very creatively, you can only do so much ultimately, and you can explore that design space and it's done. Does that result in a ghetto where it's kind of like this defines your world and you don't get out of it, versus people, is it because you have individuals that come in and say, oh, but I can do 9 other things? Is it because a new design comes along and people notice that? So is there... Right. So I think that, so the thing that I am wondering now is whether, so you do get, in a sense, like there's the whistle, and then there's the whistle thing, and once the whistle thing got there, people are still making whistles, but nobody is really designing whistles because it's kind of been done. People move on to other objects. And so I'm wondering whether there's a kind of natural life cycle in these environments. And my first reaction as somebody trained in design is, no, you can always improve whistles like that. But practically speaking, once you have the generic whistle and once you have the generic USP and like that, you can do a little bit of innovation, but it's fairly generic. And so a lot of those things will just kind of sit, and those trees will kind of die. And I think that Mako and Aaron's work on kind of generativity, some of this is, sometimes the reason we have these shallow trees
good in a way. We've built something really, really good. And because we built something really good, the needs of the community are satisfied for the time being. Now, to the other part of your question, parameterized design creates a design space. And it doesn't mean that you can't do innovation in the design space, but it kind of does. In other words, you really are, the person who creates a design space, I think, is doing the hard work. What I think is on top of the parametric design, what something like Thingiverse has is it has recombination. And that's where things get interesting, because you can take parametric designs for creating names, and you can take parametric designs for whistles, and you can put names on whistles. And so it's the recombination that gets you out of that ghetto, I think. I think that's, that and the fact that there are always new people coming in the community, starting off with new designs, so you have new populations coming in. So I think that, I was a little bit afraid that this meant, I started to see these things where you get to the customizer and it ends, but I think that might be natural, and it might be interesting to study whether or not there is a natural life cycle to some of these things, and maybe we shouldn't expect, the tree depth in these environments to be 50 or 60. Maybe 5 to 10 is kind of like the right thing, and it's not bad if if it stops after that, it's because it's fulfilled a set of needs. Yes?
One of the questions you brought up is the sort of life circle, and I wonder if you have done, thank you. I wonder if you've, what's your thought on the sort of the role of context in influencing the life circles? Because you brought up the CC Mixter case, which is a music remix community. It's a special case, but this, one of the examples about that is, you have sort of contests going on, but then people went for those famous musicians. So they went there for the contest and just keep their sort of activities going on for about a while and then just die down, right? Versus the other sort of types of activity, which is basically more random. They just search for maybe what is more visible in the community for reuse, and that kind of gets back to the level of I would say remixability or reusability, right? So that kind of gets back to the relationship between reusability and modularity. But then I think my question is, what do you think of the role of context in terms of influencing the life circles in those type of reuse communities? Does that really pose a positive image of life circles, or it actually sort of just keep it going for a while and then just,
Yeah, okay. And so maybe my timing is such, I should probably take this as the last question. Is that right? I'm not sure who's, Brian, no, sure.
It's your last question.
My side. Okay, so I'm going to answer it. I'm going to answer it in a more general way. I think there's a lot of different parts to it that I think are extremely interesting. I think contests are, we're engaged in contests all the time. We have special issues. We have grants we go for and like that. They're incentivizing, and they do move communities. When Kevin was in NSF, he was able to move an entire community by essentially creating contests. So I think they're very valuable. I think they do tend to, once we had a socio-technical systems program a long time ago, there's a whole lot of papers that said socio-technical systems, and now we have cyberhuman, and I predict there'll be a lot of papers that say cyberhuman. So it does have this it does have a clustering effect. I don't think that's necessarily bad. I will say that, like in CC Mixter, what's interesting is that things like, it makes sense, things that get reused a lot are things like drum loops, because they're very modular. They don't have to necessarily be by famous people. And so I think that in these remix communities, you can think about language as being the thing we reuse the most. And language has this really interesting optimization, which is that if you use something a lot, it becomes standard and kind of compressed into a word. If you don't use something very often, you reconstruct it by bandying together all these elements, parts of words and words, in order to express your opinion. And so over time, you have these nice distributions in language, because over time, you want to, you don't want to store everything, because you might not say this sentence again, so you can forget about it. But in other cases, if you find you're using, cyberhuman a lot, then that becomes like a phrase, and it becomes, it becomes kind of like in the graphs. That would be something that would start to pop out. And so I kind of think these remix communities are one way to try to find a more universal modeling of reuse would be to look at language and say, when is the point at which things are kind of become a thing, and what is the point at which we reconstruct them from modular components, and are we seeing modularization like drum loops happening in these environments if we pull back and look at them from afar? Thank you.
Thanks again.